Hello everyone, we are back again with you for the third episode of this video series prototyping a light duty conveyor belt. In the previous episode we have covered how to get from this, which was mistakenly designed, to something like this, and we also identified the differences between a roller, which rolls around the shaft because it has a ball bearing inside it, and the difference between a roller and a drive pulley. The drive pulley is a solid piece without having a ball bearing, because we want to connect that to our 12-volt little DC motor. So we are here after this part. The T-slot frames are connected to the roller via this part that was 3D designed. You can find the 3D design elements from the previous video. I am now going to show you how to design a drive pulley. Okay, in the previous episode we have identified the differences between a roller and a drive pulley, and that was the ability to rotate around the shaft. For a drive pulley we don't need that. We want the whole thing to be a solid, rigid part. So I don't have that in my stock, so I decided to design it 3D print and be made out of PLA, which material wise is not going to be as strong as our roller, but anyways, that's the only option we have at the moment, and not a problem. It's just a prototyping practice, and moreover it's a light duty conveyor belt. So the outer diameter of the shaft was just measured to be 7.7, similar to the roller. So just again to recap, we are going to 3D design the drive pulley, which is being connected to our DC motor running the light duty conveyor belt. And so let's move on. And this cylindrical part is going to be extruded we need to extrude this cylinder by an amount of 24.5, and then a circle with a diameter of 25 millimeter is on top of this cylinder. So we're sketching on this plane a circle with a diameter of 25. That looks sweet. But how long are we going to extrude that to be similar to our roller? The value is 10, or actually 100 millimeters, 10 centimeters. So you're extruding this part for 100 mil. Again on this surface we want to have the shaft 7.7 diameter. I'm going to be extruded for 24.5, but there is a consideration here, and that is we want this end of the shaft to attach the motor shaft, and the motor shaft in our example is 6 mil wide. So what we need is to make a shear on this surface 6 mil wide. It's a little bit tight. Now the shell, the walls are going to be really thin, and there's a really good chance for it to break, but we'll give it a try anyways. If it didn't work, we're going to change either the ball bearing or the motor. So this one we need to remove by the length of, let's say, 5 mil or 6 to be safe. The more friction we give it, the more strength we're gonna get. Okay, so that's our drive pulley now. Right, next we're gonna 3D print this part and connect it to our DC motor.